Oh, great. We're recording now. You'll notice that for the entire period, LAMP is outperforming Blend 3.2. We also did some bias verification and found that our hypotheses about how Blend version 3.2 was behaving were indeed correct. This chart shows the bias for the ceiling height of less than 1,000 feet. On this chart, a bias of 0.5 indicates that the event is forecast half as frequently as it's observed, and a bias of 1 indicates the event is forecast as frequently as it's observed. You'll notice in the teal line that Blend 3.2 was only forecasting ceiling heights of less than 1,000 feet, with about half the frequency that they were actually being observed. Whereas the other models, including LAMP, were forecasting ceiling heights in a similar frequency to how they were being observed. This verification also held up when we looked at forecasts of visibility. We looked at forecasts of visibility being less than 3 miles, and again found that LAMP outperformed Blend 3.2 for the entire period, pretty much. And with regard to bias, we again found that Blend 3.2 visibilities were forecasting visibilities of less than 3 miles only half as frequently as they were being observed, whereas LAMP is forecasting them about or just a little bit more frequently as they're observed. We tend to train these models to actually forecast them just a little bit more than they're observed and lean on the side of being a little bit over aggressive in the forecast rather than missing events. So that's why you'll oftentimes see the bias of these LAMP and MOS models being just over 1. So that was, we're just looking at verification for the first 36 hours, which was from the LAMP model, which we already had. But we also made a new model for the extended time frame from 40 to 60 some or 70 some hours. In this case, so we wanted to see how that model behaved as well. We found that it was greatly superior to Blend 3.2, and actually we identified a pretty notable issue with 3.2 in this time period, and this is likely has to do with how we were combining so many models together and averaging them and basically just producing too few low forecasts. So note again, or in this figure, this red boxed area is the verification of the new model for the extended time frame, whereas the teal is version 3.2. So LAMP has probabilities underlying it, so we're also making those probability forecasts available through the National Blend of Models. I've included here an illustration of a sample forecast for probability of ceiling height being less than 1,000 feet. Note that the brighter colors indicate a higher probability. So in this case, there's a high probability of ceiling heights being less than 1,000 feet across much of the northeast coast and through a good part of the middle of the country, whereas a good part of the west actually looks like it's a pretty low probability of low ceiling heights, at least for the inner west. Along the coast where you have the stratus, you can see where there's the higher probabilities of ceiling heights less than 1,000 feet. With probability forecast comes probabilistic verification. We wanted to see how reliable the forecasts were, especially in the new time frame where we produced the new model. This is what we refer to as a reliability diagram. It includes the forecast probability of ceiling height less than 1,000 feet on the x-axis, and the relative frequency of ceiling height less than 1,000 feet on the y-axis. One can interpret this as when for the events where the probability forecast was around 40%, the event occurred about 40% of the time. So ideally, we'd see this blue line track very close to the diagonal, and you can see that it is tracking fairly close to the diagonal, so we consider the forecast fairly reliable. We're also making the probability forecast available through the National Blend of Models text bulletins. We've included a few new lines for these probabilities. For ceiling, you'll notice this MVC, IFC, and LIC. The C is for ceiling, the M is for marginal, the I is for instrument, and the L is for low. So the marginal is for less than 3,000 feet, the instrument for less than 1,000 feet, and the low for ceiling height of less than 500 feet. There's an analogous code for the visibilities being less than 5 miles, 3 miles, and 1 mile. So one could look at the bulletin to get a understanding of how likely an event that may impact them would occur. One should always, when interpreting the probability information, one should always keep in mind that some of these rare events, like visibility less than 1 mile, will oftentimes not have very high probabilities associated with them because they're rare events. So for example, just like a tornado is rare, but a 2% probability of a tornado in a 10-mile area is actually very high, even though the number 2 is fairly low. So one should keep in mind that rare or unusual events do not usually have high probabilities associated with them. We have a number of other updates with version 4.0. Well, first off, the numerical weather prediction under these models is being updated, like the HRR model. The HRR model made pretty considerable improvements to their sky cover with their new version, and we've seen the blend take these better model inputs and these translated to a better blend forecast. For example, we've seen the blend sky cover now present to us much more spatially coherent and apparently better forecast for stratus along the West Coast. So these results are encouraging, and we've heard positive feedback about how the new sky cover forecasts are behaving. We have this update, and there's actually a number of updates for version 4.0, and there's a host of weather information available in the blend. So I'd encourage you to check out our website if you're interested in the new guidance or the operational guidance that's being made available, and also continued development efforts. With that, I'll leave you with my contact information and also our website where you can go to find more information on the National Blend of Models. Thank you very much.
Unmute.
Oh, let me leave this up. Let me leave that up. And Dawn, I don't know if we have time for questions or not.
All right, thank you very much, Adam. I apologize for the delay. I had a quick tech difficulty and my computer froze up. We do have a few questions in the chat. First one, have you given any thought to create an NBM model for the Core 30 airport thresholds? Yeah, I gotta find them again. All right, Adam, I'm going to try to unmute you here. No, cancel. All right, Adam, I'm trying to unmute you.
Can you hear me now?
I can hear you now. Thank you very much.
Great.
All righty. And in the chat room, there are about 4 questions, and you can read those if it's a little bit easier.
Okay.
First one was, any thought to create an NBM model for the Core 30 airport thresholds?
We've considered it. At the moment, we only have, for ceiling height, probability of less than 3,000, 1,500 feet, and for visibility, probability of 1 mile, probability of visibility less than 1 mile, 3 miles, and 5 miles.
All right.
Some of the airports that have different thresholds, we don't have exactly that, but those probabilities can still provide awareness for what the other ones may be.
All right, thank you. Next question we have, I like the new approach. For cloud-based height, will the NBM continue to mask out the values for areas that do not have a cloud? I'd like to see a pure cloud-based height that ignores sky cover.
Thanks for the question. That's a great question. We're going to revisit that with the next version. We have, in fact, observed that sometimes the tight coupling with the sky cover produces artifacts or can remove the ceiling height when, in some cases, that may be undesirable. In other cases, it's actually done the forecast good. So we're going to revisit that with the next version of the blend and potentially at least loosening the coupling between the sky cover and the ceiling, because in my opinion, it's a little bit tight now, and it can do some pretty good harm in some events.
All right, let's see. When is 4.0 coming?
I believe it's Q4 of this year. I don't have the date on the top of my head, but shoot me an email and I can get you the expected implementation date.
All right, thank you very much. Let's see. We'll probably have time for one more question, and then if you look at the chat room, you'll see the last couple questions in there. One person asked, I was just wondering if there were any studies that evaluated different areas and how NBM, along with the other models, perhaps differ based on location.
Good question. We tend to do so from a national blend perspective. We're aware that different models will perform differently in different locations. LAMP actually kind of considers that, and the development is regionalized, although it will certainly perform better in some locations than others. And some of the numerical weather prediction models, for example, in some cases, a direct model output from, say, the HER may provide more awareness for what's going on in sometimes complex terrain versus an analyzed product, which is taking point data and spreading that over the grid with a number of assumptions. So I don't have any formal studies on the top of my head with regard to what types of environment various models do best at.
All right, that is it for time. Like I said, you have one more question. If you can take a look at the chat and maybe address it in there, I'm going to try to hand things over a bit more smoothly to our next speaker, Dr. Schaefer. Let's see if I can get things to transition a bit more smoothly than before. There we go. All right, Dr. Schaefer, I've just offered a presenter role to you. And once you accept that, I think it will be able to unmute you as well. All right, I now have you as the presenter and able to see a contact slide. You want to go ahead and give your audio a test. Let's see if we're going to try one more time with your audio, see if I can get it transitioned. All right, Phil, I am not able to unmute you. Everyone All right, Phil, I'm still having trouble with your audio.